guys, welcome back to my YouTube channel. So in this video, we're going to discuss another set of topic in mathematics, which is all about evaluating a function given the indicated value. So I have here examples to be shown in this video. So for number one, let us proceed directly. For number one, we have the given function is we have f of x equals to 3x minus 1, and we have to evaluate that one using the indicated value at f2 and f1 over 6. So let us proceed. Meaning to say, we have to evaluate the function f of x is equals to 3x minus 1 given these indicated values at x equals to 2 and x equals to 1, 6. So we have to substitute directly our value, which is 2 and 1, 6, to the given expression, or I mean function. So we have at f2, so we have at f2 or x is equals to 2, so the value of the function will be determined. So just replace the variable x with the indicated value of x, which is 2. So minus 1. So let us simplify this one. So f2 then is equals to 3 times 2, that is 6, then minus 1. Then we have f of 2, or f x at 2 is equals to 6 minus 1, that is 5. So this is already the answer. So after we evaluate the function f of x equals to 3x minus 1, given that the value of the variable x is 2, is equals to 5. Next we have what is the value, or how to evaluate the function if the value of x is 1, 6. So we have to rewrite again the function to avoid confusion. So that is over 1, I mean minus 1. So we have f of x equals to 3x minus 1, that is the given function. So we have to substitute x with 1, 6. So at f1, 6, so that is equals to 3 times 1 over 6 minus 1. Again, just simply substitute the indicated value to the expression or to the function. So we have here now 1 over 6, f of 1 over 6 equals to 3 times 1, 6, that is 3 over 6 minus 1. So we can simplify it further. That is 3 over 6, or that is 1/2, because we can reduce this one to lowest term. So 3 over 6, that is equivalent to 1/2 minus 1. So since they don't have the same denominator, we have to get the LCD between 1/2 and negative 1. So the LCD between 1/2 and negative 1 is 2. So that is why 2 divided by 2, that is 1, times 1, that is 1. Then 2 times negative 1, that is negative 2. So simplifying further, that is equals to 1 minus 2, that is negative 1, all over 2. So this is the final answer. So the value of the function at x is equals to 1, 6 is negative 1/2. So let us proceed to example number 2. So our example number 2 defines the function g of x is equals to negative 3x minus 1/5. So we have to find g, or the function g at negative 2, or the value of x at negative 2, and function g at value of x, which is equals to 0. So again, just directly substitute this one with the variable, or in the x variable in our given function. So we have now to at g negative 2, so negative 3 times negative 2. So replace x with negative 2 based on the given indicated value. So minus 1/5. So g negative 2. So negative 3 times negative 2, that is positive 6, minus 1/5. So simplifying further, that is 6 minus 1/5. Since they don't have the same denominator, we have whole number 6 and a fraction number which is 1/5. So the least common denominator between 6 and 1/5 is 5. So 5 times 6, that is 30. Then 5 divided by 5, that is 1, times negative 1, that is negative 1. Then we have to simplify further. 30 minus 1, that is 29, then over 5. So since we can no longer simplify or reduce this fraction to lowest term, so 29 over 5 is already the answer, since we can no longer reduce this one into lowest term. Next, we have to find or evaluate the function using g at z0. So we have to rewrite the function again. G of x equals to negative 3x minus 1/5. That's it. So g at g0 that is to replace x with 0 minus 1/5. So this is very easy since we are just going to substitute directly the given value. So negative 3 times 0, that is 0 minus 1/5. So z0 at z0, 0 minus 1/5 is negative 1/5. So the value of the function, given that the indicated value of our function is 0, is negative 1/5. So this is now the final answer. So let us move to example number 3. So for example number 3, we have the function, the given function here is we have h of x is equals to 1/4 x plus 3. Then we have to find or evaluate the function using the indicated value at negative 8 and 4/5. So at negative 8, so we have to replace x variable with negative 8. So it will become 1/4 times negative 8 plus 3. So as simple as that. Direct substitution only. So the process here is just, the process involved here is just direct substitution. So h negative 8 is equals to 1/4 times negative 8, that is negative 8/4 plus 3. Then simplifying further, negative h negative 8. So let me write it correctly. So h negative 8 is equals to negative 8 divided by 4, that is negative 4. I mean negative 2, sorry for that. Negative 2 plus 3. This is negative 2. Okay. So we have negative 2 plus 3, that is 1. So this is already the final answer. Meaning to say, the value of the function defined by h of x 1 is equals to 1/4 x plus 3 is at h negative 8 is 1. Okay. So let us evaluate the function using the value of the indicated value, which is 4/5. So we have now to rewrite the function again, which is h of x 1/4 x plus 3. So then the indicated given value is equals to 4/5. So again, we have to replace the variable x with the indicated value, which is 4/5, then plus 3. So after that, h 4/5 is equals to 1/4 times 4/5. As you can observe, we can cancel out 4 here. So the remaining number in the numerator will be 1, and the remaining number in the denominator will be 5, since we already cancelled out 4. So plus 3. So we have to simplify this one further. 4/5 is equals to 1/5 plus 3. So the least common denominator will be 5. So 5 divided by 5, that is 1 times 1, that is 1. Then plus 5 times 3, that is 15. So h at 4/5 is equals to 1 plus 5, that is 16 all over 5. So since this can no longer be reduced into lowest term, so we can consider this one as our final answer. So the value of our function defined by h of x is equals to 1/4 x plus 3, as the indicated value of x is at 4/5 is 16/5. So let us proceed to the last example for this video. We have example number 4, defined by the function f of x equals to square root of 4x minus 8. Just a little reminder that in this example, negative 8 is not included in the radical sign. So we have to find the value of the function at f4 and the value of the function at fx squared. So first, we have to substitute 4 in the given function. So at f4, so you will get square root of 4 times 4. So we just simply substitute x with 4 as one of our indicated value here. So minus 8. Now then we have f of 4 is equals to the square root of 4 times 4, that is 16, minus 8. So we have to simplify further. Square root of 16. Since 16 is a perfect square number, then we can get the square root of 16, that is equals to 4. So minus 8. Again, square root of 16, that is 4. Then minus 8. So f of 4 is equals to negative 4. 4 minus 8, that is negative. Again, 4 minus 8, that is negative 4. So this is already the value of the function defined by f of x equals to square root of 4x minus 8 at the indicated value of our function, which is equals to 4. So the value is negative 4. So this is now the process of how we evaluate the function. Next, we have the indicated value, which is x squared. So we have to rewrite again the function to avoid confusion. 4x minus 8. So we have to replace x with x squared. So we have f of x squared is equals to square root of 4 times x squared. So again, x here was being substituted with x squared, then minus 8. So negative 8 is not included in the radical sign, so it is, as you can observe here, it is not included also. So f of x squared is equals to square root of 4 times x squared, that will become 4 times x squared, that is 4x squared, minus 8. So f of x squared, so we have square root of 4, that is 2, then we have square root of x, that is x, minus 8. Since we can no longer simplify this one into lowest term, so we can consider this one as our final answer. So that is the process on how to evaluate a function using the indicated value or given the indicated value. So I hope you understand something about the explanation I provided based on the capacity, on my capacity and capability to explain the concept on evaluating each function here. And thank you for watching. God bless everyone.